We'll finish our section 1.2 on quadratics, solving quadratic equations by looking at some problems that can be modeled by quadratic equations, some application problems. So example 5 says that Brad has a rectangular flower garden with an area of 55 square meters. The perimeter of his garden is 32 meters. Find the lengths of the sides of Brad's garden. So a length, they don't just mean length, but the length of the side. So what's the length and what's the width? What are our sides? They don't necessarily care which one's which here. They just say, what are the sides? Measure. Include units with your answer. So again, let's look at a little sketch. He's got this rectangular garden with length and width and length and width. And we're told that the area equals 55 meters squared. And the perimeter is 32 meters. But what is the formula for the area of this rectangle, of any rectangle? Right, it's length times width. And we've seen before the formula for perimeter. We want 2 lengths plus 2 widths. Okay, so we've got these two equations, two unknowns. We need to get an expression for one of them using the other. So I've got this 55 equals length times width. So I could solve for L and say, okay, L is equal to 55 divided by W. And then I can replace L in my perimeter equation, which says 32 equals 2 L's, but L is 55 divided by W plus 2 widths. Don't forget those. Okay. So distribute 32 equals 2 times 55 is 110 over W plus 2W. Now this looks really weird, doesn't it? But we know how to get rid of fractions. We've got a fraction there, is if we multiply by the common denominator. And there's only one denominator, it's W. So I'm going to multiply every single term by W. So I get 32W equals, when here it will cancel, 110 plus and 2W squared. There we go. Now we see why this is under quadratics, right? We have a second degree. Okay, I'm going to come over here. This is not in standard form, number one. Number two, I prefer my A, my first term, my coefficient of the squared term, to be positive. So I'm going to subtract 32W and get it on the side with the 2W squared minus 32W plus 110 equals 0. So I put the 0 on the right-hand side and I subtracted 32W from both sides. Now I've got it in standard form. Okay, well, I could go straight to the quadratic formula. It doesn't say what method to use. I don't have to use complete the square or factoring, whatever. It doesn't say. So, but I'm looking at this and seeing 3 even numbers, so I'm at least going to pull that 2 out to make the numbers smaller. Even if I am going to go to the quadratic formula, I'd much rather have small numbers to use for A, B, and C. But now I see this and I think, you know what? 55, what are the factors? Yeah, 5 and 11. That's it, right? And if I make them both negative and add them, 5 and 11, I got that. So I'm not going to bother with the quadratic formula. I know this is W minus 5 and W minus 11. That one was just too easy. So W minus 5 equals 0, and W equals 5, and W minus 11 equals 0, and W equals 11. Now how can I get two different widths? Well, what this is just telling me is one of the lengths of my sides is 5, and the other one's 11, and you can call them what you want. I mean, maybe we think length is longer than width, but not necessarily. So let's just say, it says find the lengths of the sides. So the lengths of the sides are 5 meters, these were meters, right? And 11 meters. It doesn't say, you have to say which is which. That's our answer. Okay, in the next example, we have an object propelled vertically upward with an initial velocity of 19.6 meters per second, and we're starting from the top of a platform that's 58.8 meters tall. So I don't know, see if I can sketch this over here a little bit. Let's see. We've got a platform here. Here's the ground. So our object's going to go up, and of course, gravity's going to pull it down. So that's what we've got, and this is 58.8. from the ground to the top of the platform where the object's going to be projected. Okay, the distance S, so S is distance in meters of the object from the ground after t seconds is given by this quadratic equation. This is how high it is off the ground, S. T is how long it's been since the projectile was projected. So when will the object strike the ground? So that when S or T? It's T, right? Because T is in seconds. That's time, right? So we're looking for T, and it says object strike. They didn't tell us how high it is, but they're saying it hit the ground. And S is how far it is from the ground. So how far is it from the ground when it's on the ground? Well, so S is 0. T is what? That's the question. Okay, so we're going to put in 0 for S. And we're going to solve for T. Now, we could go straight to the quadratic, but I look at these numbers and I go, yeesh, is there any way, is it possible that each of these could be divided by negative 4.9? Wouldn't that be lovely if they're all divisible by negative 4.9 and I would have integers there? So I give it a minute and try that. And when you try that, guess what? In this part, they definitely are. When you divide 19.6, and I'm going to divide by the negative because I want that to be 1t squared. Wouldn't that be great? 19.6t divided by negative 4.9 and 58.8 divided by negative 4.9. Turns out they all divide very nicely. And what do we get? Of course, this is my 1t squared. This becomes negative now. Be careful with that. Divide a positive by a negative, you get a negative, and it's 4. 4.9 goes into 19.6 4 times, and this is 12. And it's also negative, right? Because we're dividing by a negative. Look at that pretty little thing. That's going to be easy to factor. I'm not even going to bother with the quadratic. Two numbers that multiply to negative 12, add to negative 4. That's going to be negative 6 and positive 2. So t minus 6 is 0, and t plus 2 is 0. So t equals 6, and t equals negative 2. Now let's go back. What did they ask us? This is an application problem. The answer has to make sense. When will it strike the ground? This would, and t is in seconds, so it's telling me 6 seconds or negative 2 seconds? Well, obviously, this answer makes no sense in this real application. So I won't use that as an answer because negative 2 seconds makes no sense. So my answer is 6 seconds. In other words, 6 seconds after it's projected, it's on the ground. It takes 6 seconds to do this entire path. Okay? All right, that was the first part. Now it asks, well, when will it be 75 meters above the ground? When's it going to be up here? 75 meters somewhere. Okay, so let's find out about that. Now, that means S is what? Again, it's asking when, so that's T. S is 75. That's how high it is off the ground. T is what? That's the question. So now we put 75 in for S. Okay, if we're going to factor, if we're going to use quadratic, it has to be in standard form. So we've got to subtract the 75 to get a 0 on one side. And what do we get? This ends up being negative 16.2. Okay, try my trick again, dividing by, I know this will divide by negative 4.9, but guess what? This won't. So I don't get to do that this time. So I may want to, I know I'm going to use the quadratic formula. I like to go ahead and get my b squared minus 4ac first. So that's 9. You don't have to, but it can be helpful because what if it's negative? 4 times a times c. Notice I've got 3 negatives here, so this quantity will be negative. And what do we get? Let's see. That's 384.16. That's 19.6 squared minus 317.52. That's this all multiplied. And we get 66.64. Be careful with the signs. You can see that if I thought this was a positive number, I'd be off and way in the wrong direction, wouldn't I? Okay, so looks like we got a positive number, so there will be solutions, so here we go. So we're looking for t equals negative b, and b was 19.6, plus or minus the square root of 66.64, I already know what that is, all over 2 times negative 4.9. Be careful, that's negative. Okay, that's negative 19. And I'm going to have to take the square root of this because we're trying to get to an actual number. It will be rounded. I know I do have to round. It doesn't need to be exact. Okay, plus I have to round to tenths, which is 1 decimal place. Plus or minus, and let's see, we take the square root of that, we get 8.163 all over negative 9.8. So there's two solutions here, right? So t equals negative 19.6 plus 8.163 over negative 9.8. And let's see what we get when we do that. What does that come out to be? Negative 11.437 over negative 9.8, or 1.167, or t equals negative 19.6 minus 8.163 over negative 9.8, and that is negative 27.763 divided by negative 9.8. See if we can see this. I don't want to lose it. 2.83. I mean, I'm just going to 2 decimal places because, or 2.832. I'm going to round to tenths. Okay, we got 2 solutions. All right, they both seem reasonable. They're positive. It's number of seconds. So my answers would be, it says, when will it be 75 meters above the ground? 1.2, rounding that one, seconds, and 2.8 seconds. Now, why do we get 2 answers? Well, remember, we're starting at 58.8 feet. It must be that like 75 feet happens somewhere like here and here. So as it's going up, it hits 75, and as it's coming down, it hits 75. First at 1.2, then at 2.8. Okay, let's finish this up. When will the object be 100 meters above the ground? So now we're going to go 100. So that means S is 100. T is what? So we'll put 100 in for S, negative 4.9 t squared plus 19.6 t plus 58.8, subtract 100, 0.9 t squared plus 19.6 t. We subtract 100, we get, what? 41 minus 41.2. Okay, let's analyze b squared minus 4ac. So that's 19.6 squared minus 4 times negative 4.9 times negative 41.2. And that comes out to be negative 423.36. We got a negative for b squared minus 4ac. That means no real solution. What's happening? It never gets to 100. It doesn't go that high, right? It gets to 75, but it doesn't get to 100. So the answer, when? Never. It will never get to 100 meters above the ground.